5, 4, 3, 2, 1, 0, ignition, liftoff.
Hey guys, welcome to MB Tech Talker. My name's Matt. So in this video, I'm going to show you how to configure layer 2 interfaces on the Palo Alto virtual next generation firewall using VMware ESXi. If you want to see more videos like this, be sure to hit that subscribe button and the bell to get notified every time I post a new video. So how does a layer 2 interface actually operate on the Palo Alto firewall? Well, a layer 2 interface provides switching functions between two or more interfaces through a common VLAN object, which is part of the same broadcast domain and used when no routing is required. The firewall does not participate in spanning tree, however, SDP packets are forwarded to other network switches. When using layer 2 interfaces, the Palo Alto firewall can examine traffic shape and block traffic whilst providing app ID, content ID, user ID and QoS. Okay, so this diagram shows a simple flat network of an existing small business where a physical Palo Alto PA220 firewall has already been deployed. The network consists of end-user PCs and a single server that reside on VLAN 60. So we have a scenario. The company's security team have decided that due to the sensitivity of the data on the server, it needs to be subject to tighter security controls, allowing only approved applications to access the server, as well as the ability to provide threat prevention without the need to change the IP addresses of the clients or the server. Okay, so this diagram shows the ESXi lab configuration replicating the company's flat network. I will have to use vSwitches to emulate the client and server connectivity to the Palo Alto, as I'm unable to connect directly to the firewalls without them. The Windows 10 VM will act as the end user client, which connects to a port group called LabSwitch2 LAN 2, which is using vSwitch 7, and the Windows 2012 server VM connects to a port group called LabSwitch2 LAN 3 on vSwitch 8. Both the ETH1/2 and ETH1/3 are layer 2 interfaces which will connect to their relative port groups and vSwitches. The Palo Alto's ETH1/1 is the layer 3 untrust interface which connects to the lab router SW-LAN 2 port group on vSwitch 1, which has internet connectivity. I will connect to the Palo Alto's web UI from the dedicated management interface connected to the management PC. Okay, before we jump into the lab, let's go through the configuration steps. We will need to create a layer 2 interface for each of the virtual machines. We need to create a VLAN object, security zones, and a security policy to define which applications can be used between the client machine and the server. Once this configuration has been completed, the Palo Alto firewall will transparently switch layer 2 traffic between the end user client and the server whilst enforcing security policy. We will then confirm by completing some simple connectivity tests. Okay, so let's dive into the lab. I've logged into the Palo. Let's just go through the general information on the dashboard. So we've got a hostname configured. We've got a management address, which is the address I'm using to get to the web UI. Default gateway set. This is a VM series Palo Alto. It's got a VM50 eval license applied, and it's running on VMware ESXi, and the PanOS version is 8.1.0. Let's just have a quick look in the device tab and down at licenses at the bottom here. You can see we're using a standard VM50 eval license, which is giving us all the features such as URL filtering. So you've got the PanDB URL filtering, threat prevention, DNS security, global protect, some wildfire. So more than enough for this layer 2 configuration video, but this gives us a lot of scope for future videos. So if we can have a look at a couple of the other tabs, let's move over to the network tab, and as you can see there are 3 interfaces, and they are currently up and ready to go. However, the interface type are set to tap and virtual wire. So we'll come back to this and configure the layer 2 interface, but let's just have a quick look through the other options here. So zones, there are no zones defined, no VLANs, no virtual routers except for the default one. And if we go to policies and go to security, you can see there's two out of the box security policies defined called intra-zone default and inter-zone default. And then under the NAT option, you can see there is no NAT configured. So if we move back to the network configuration and back to interfaces, let's start setting up the layer 2 configuration. So if we go into 1/2, this is going to be the end user layer 2 interface. We just add that into the comments. Interface type is going to be layer 2, and if we do assign interface to, you go to VLAN and hit the drop down. As you can see, there isn't a VLAN defined yet, so if we click on new VLAN, and then I'm just going to call this VLAN 60, and then click OK. And the same for security zone. Again, there isn't a security zone defined, so if we click on new zone, and this one is going to be end users, and then just click OK on that, and then click OK. And we'll do the same on Ethernet 1/3. This will be server layer 2 interface in the comments, or in the comment. The interface type again will be layer 2, and then assign interface to VLAN. VLAN 60 is there now. In the security zone, we don't want to assign the server to the same zone as the end users. We want to create a new zone, so we're going to call this servers, and then click OK, and click OK. So let's just go through this configuration. So at the moment we've got two layer 2 interfaces. They're up, and they are assigned to a VLAN object called VLAN 60, and they are each assigned to their own security zone. So this is very similar to creating a VLAN on a Cisco switch. You would create the VLAN, and then you would assign the switch port to the correct VLAN. However, the difference is this is a firewall, so it is doing switching at layer 2, but it's also doing security policies. Because this is a zone-based firewall, we're able to assign a zone to each of the interfaces, so that we can then define a security policy permitting or blocking what traffic we want between the zones. So if we move on to the policy, we need to create a simple policy to allow traffic to go between the end users and the server. So if we just click on add, and we'll just call this end users to server, or servers, sourcing from the end users security zone destined to the server security zone, and we're only going to allow ping for testing purposes. So if you just type in ping there and then select it from the application list, if you go to service, that needs to be application default. Action is to allow, and then log at session end, and then click OK. So then we should be able to see the permitted traffic turn up in the monitor tab. So once we've done that, let's commit that change, and while that's committing, we can go and verify the Windows client and the server. So if we go to the Windows 10 machine and then open up a command prompt, and then just verify the ipconfig. It's 172.16.60.20. There's no default gateway. If we go over to the Windows 2012 server and do the same over there, cmd, and then do an ipconfig on this one, you can see this is set to 172.16.60.100. So let's have a look at the Palo. Okay, so the change is committed successfully back to the firewall. Close that, and now let's just do a couple of ping tests to confirm. So if we go back to the Windows 10, we're going to ping the server IP, so ping 172.16.60.100. That's good, so we're able to ping the server. If we go to the server, can the server ping the client? 172.16.60.10. And the answer is no, which is what we expect. If you go back to the Windows 10, what we're going to do now is see if we can RDP to the server. So let's open up an RDP window. So there's the IP address of the server. Can we connect? Doesn't look good. So we go to the Palo, go to the monitor tab, and you can see we've got pings being allowed through from the client to the server. So pings allowed. So as you can see, that configuration's worked. So we've allowed only ping from the client to the server because we've got a security policy. Even though they're on the same layer 2 broadcast domain, we're able to control what is being allowed between the two machines. So let's change that, and let's take this a little bit further. We go to policies, and now open up the policy that we created, and then we're going to go back to application, and then we're going to add a new application, and I think we need MSRDP. So if we click that, Microsoft Remote Desktop Protocol, and then click OK, and what we'll do, just to make this a little bit more kind of bi-directional, let's add another policy but doing it the other way, and we're going to call this servers to end users, and we're going to do sourcing from the servers this time to the end users, and application add, and we're just going to add ping so we can at least get a connectivity test going back the other way. So select ping, service is application default, allow, log session end, OK. So if we now commit that and just wait for that, you can see we've got some hits on the rules. So we're seeing the traffic from the ping on the end user to server rule. And hopefully once this is finished, we'll be able to go back to the Windows 10 clients and try a remote desktop connection to the server. So let's go back to Windows 10. So as you can see, that failed that time, and let's try again. Let's see if this is going to work this time. And there you go. So ultimately, because we got the login box, let's see if I can log in. And there you go. So we've got a successful RDP window to the server. And whilst we're on the server, we can do the test going back the other way. So we're on the server now. So let's try and ping the end user client. And there you go. So that configuration has worked as expected. And that is exactly how you can set up layer 2 interfaces and apply security policies using a Palo Alto. Okay, so now we've configured the layer 2 connectivity between the end user client and the server. I want to take the lab a step further by ensuring that there is network connectivity to the internet. The first step is to complete the layer 3 configuration on Ethernet 1/1 by configuring an IP address, security zone, security policy, NAT policy, and a virtual router to set the default gateway to the internet router. The second step is to configure the layer 3 VLAN interface, which will act as the next hop address for the VLAN 60 clients to reach the internet. We will also need to configure the required security policies and NAT policies to complete the configuration. Okay, so let's complete the interface configuration. So go to the network tab, and we're going to go to Ethernet 1/1. This is the interface that connects to the internet router. So we're going to change that to a layer 3 interface type, and then we're going to assign it to a new virtual router. I'm going to call that VR1, and then click OK on that, and then we're going to assign it to a new security zone, and that's going to be called Untrust. Click OK. Then we need to assign it an IP address. So that's going to be 172.16.10 172.253/24. The next hop, or the router that it connects to, is .254. We'll set up a default route in the virtual router in a bit, but click OK on that. So that completes that layer 3 interface. Next we need to do the VLAN interface. So this is the same as like a layer 3 switch interface. It will act as a default gateway for the VLAN 60 clients. So just go to the VLAN tab under interfaces and then click add, and then we're just going to put 60 in there as an identifier. This doesn't correspond to any VLAN tagging. This is just for identification purposes. And then we're going to assign it to the existing VLAN 60 VLAN object, and then the virtual router will be VR1, and we're going to create a new zone for this, and I'm just going to call this trust because this is on the inside of the firewall. And then click OK, and then we're going to give it an IP address, so it needs to be on the same subnet as the VLAN 60 clients, so that'd be 172.16.60.254. so this will be the default gateway. /24, click OK. So that's the interface is now configured, and now we can move on to the security policies and NAT policies. Okay, so we're at the policies tab, and we're going to create a new NAT policy. So select NAT and then go to add, and then we're going to call this outbound NAT. And then we're going to click on the original packet tab, and under source zone we're going to choose trust. This is the security zone that's been assigned to the VLAN interface, so the layer 3 VLAN interface. We're going to choose destination zone as untrust, which is the Ethernet 1/1. Destination interface, we're going to select the interface. Service is any, source address is any, destination address is any, and then click on the translated packet. So translation type will be dynamic IP import, and then the address type, we're going to have interface address, and then the interface will be Ethernet 1/1, and we're going to NAT everything to the interface IP 172.16.10.253. This means that the upstream router will know how to respond back to traffic that comes from the VLAN 60 client addresses. So we're going to select the IP address, and then we're going to click OK. So that's the NAT policy. The next thing we need to do is create a security policy, and from here we're going to add a new security policy for the trust to untrust. So we're going to do trust to untrust. So this is the trusted security zone, which is attached to the VLAN interface. So users will use the trust layer 3 address as a default gateway to get to anything that isn't on their local subnet. So we're going to choose the source zone to be trust, the destination zone to be untrust, and then we're going to have applications any, service any, actions allow, and log session end. Now these are very permissive rules, but this is just in a lab just to prove connectivity. Obviously all of these rules can be reconfigured to be more stringent on what's allowed from the security zones, but yeah, just for this for testing purposes, I'm just going to allow anything out to the internet. And then what we need to do from here is we need to also configure the default route on the virtual router. So we need to go back to the network tab and go to virtual router and go to the VR1 virtual router, and click on static routes and then add, and give it a name. I just normally call it default route, and destination is 0.0.0.0/0. That's anything. so that's any destination network. Then the interface is going to be Ethernet 1/1. The next hop address is going to be the upstream router, so that is 172.16.10.254, and then we can click OK on that, and then click OK. Another thing we may want to do just to improve connectivity is go back to interfaces, and on the VLAN 60 interface you can assign a management profile, and we don't have one, so I'd like to confirm that we've got connectivity to that layer 3 interface from the client and from the server on VLAN 60. So let's create a new management profile, and let's just call it ping. So ping management, and then just select the ping network service there, and then click OK, and then OK. And then if we commit that, commit, and then we can go back to the Windows 10 client to start with, and I don't know if you remember that we don't have a default gateway set on the network card. So if we go into network internet and go to the actual adapter settings, and then go into the IPv4 configuration and set up a default gateway 172.16.60.254, and click OK. And we'll do that on the server as well. So let's open control panel, network, and adapter settings, properties, and IPv4, and then same on here, 172.16.60.254. Click OK. OK again. Close that. Close these windows, and then we're going to open up a command prompt, and then we test that we can actually ping the layer 3 VLAN interface. So ping 172.16.60.254, which we can. That's great. And now we should be able to test out to the internet. So if we were to ping 8.8.8.8, yeah, we've got access to the internet, so that's great. So let's just go to the Windows client over here, so I can use Chrome. I open up Chrome, and then we can go to www.google.com, and hopefully if I choose Facebook and then click on that, and that proves that we've got internet connectivity. And if we go back to the Palo Alto and we go to the monitor tab, we should be able to start seeing traffic going out to internet addresses. See port 80 and SSL, DNS. So let's recap on this configuration. So we got our interfaces, we got our layer 2 interfaces connected to the clients, we got a layer 3 interface connected to the upstream router, and then we've got the VLAN interface, which is used as the layer 3 interface for VLAN 60, and we've got a virtual router set up with a static route, and we've got traffic flowing through. So ultimately that is a full configuration of layer 2 interfaces with a security zone and access out to the internet using a layer 3 VLAN interface. So that has been a successful demonstration. Hope you enjoyed that. Let me know how you got on, and I'll see you in the next one. Okay guys, that's it for today's video. Thanks for watching. Over the next coming weeks, I will be uploading more videos where I will be sharing more content about Palo Alto firewall features and technologies and how to configure them. If you like this video, I'm sure you know what to do by now, but just in case you don't, please hit that like button below and share with your friends, and be sure to hit that subscribe button and the bell to get notified every single time I post a new video. If you have any ideas of video content you want me to create, please put them in the comments below, as I would love to hear your feedback on any aspect of my channel. Please keep watching, and I will see you in the next video. Thanks.